Welcome to the channel of Vedant classes. Today we will see the chapter 4 Carbon and its compounds. Occurrence of carbon. Carbon is found in the atmosphere inside the Earth's crust and in all living organisms. Carbon is present in fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, Mars gas, etc. Carbon is present in compounds like carbonates, hydrogen carbonates, etc. Carbon is found in free state as diamond, graphite, fullerenes, etc. Bonding in carbon covalent bond. The atomic number of carbon is 6. Its electronic arrangement is 2,4. It has 4 valence electrons. It can attain stability by gaining 4 electrons, losing 4 electrons, or sharing 4 electrons with other atoms. It does not gain 4 electrons because it is difficult for 6 protons to hold 10 electrons. It does not lose 4 electrons because it needs large amount of energy to lose 4 electrons. So it shares 4 electrons with other atoms to attain stability, resulting in formation of covalent bond. Since carbon atom needs 4 electrons to attain stability, its valency is 4 and it is tetravalent. Formation of covalent bonds. Covalent bond is a chemical bond forming by sharing of electrons between atoms. The sharing of one pair of electrons resulting in formation of single covalent bond, sharing of two pairs of electrons results in formation of double covalent bond, and sharing of three pairs of electrons results in the formation of triple covalent bond. Example, formation of single covalent bond in hydrogen molecule H2. The atomic number of hydrogen is 1. Its electronic arrangement is 1. It has 1 valence electron. It needs 1 electron more to attain stability. So, 2 hydrogen atoms share 1 pair of electrons, resulting in formation of a single covalent bond in hydrogen molecule H2. Formation of double covalent bond in oxygen molecule O2. The atomic number of oxygen is 8. Its electronic configuration is 2,6. It has 6 valence electrons. It needs 2 electrons more to attain stability. So, 2 oxygen atoms share 2 pairs of electrons, resulting in formation of double covalent bond in oxygen molecule O2. Formation of triple covalent bond in nitrogen molecule N2. The atomic number of nitrogen is 7. Its electronic configuration is 2,5. It has 5 valence electrons. It needs 3 electrons more to attain stability. So, 2 nitrogen atoms share 3 pairs of electrons, resulting in formation of triple covalent bond in nitrogen molecule NT. 2 hydrogen atoms, hydrogen molecule, fluorine atoms, 2 fluorine atoms form fluorine molecule, 2 oxygen atoms and 1 carbon atom form carbon dioxide molecule, 4 fluorine atoms and carbon atom form a molecule of carbon tetrafluoride. Electron dot structures of methane CH4 is shown here and ethane molecule C2H6. Formation of very large number of carbon compounds. Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 million. It is more than the number of compounds formed by all other elements. This is because carbon atom can form bonds with other carbon atoms to form long chains, branch chains and closed rings. This property is called catenation. Second, since the valency of carbon is 4, it can form bonds with other carbon atoms or with atoms of other elements like hydrogen, oxygen, nitrogen, halogens, etc. Long chain of carbon, branch chain and closed ring is shown here. Hydrocarbons, saturated and unsaturated hydrocarbons. Hydrocarbons. are compounds containing carbon and hydrogen atoms. Saturated hydrocarbons are hydrocarbons having all single covalent bonds between the carbon atoms. Alkenes have all single covalent bond between the carbon atoms and their names end with N. Methane CH4, ethane C2H6. Unsaturated hydrocarbons are hydrocarbons having a double or triple covalent bond between two carbon atoms. Example, alkenes and alkynes. Alkenes have double covalent bond between two carbon atoms and their names end with ene. Ethene C2H4, propene C3H6. Alkynes have triple covalent bond between two carbon atoms and their names end with ine. Ethane C2H2, propyne C3H4. Isomerism. Carbon compounds having same molecular formula but different structural formula are called isomers. This property is called isomerism. Example, butane C4H10 has two isomers. They are normal butane and isobutane. Pentane C5H12 has three isomers. They are normal pentane, isopentane and neopentane. Functional groups. An atom or group of atoms which decides the properties of a carbon is called a functional group. Halide, halo group. Chlorine, bromine, etc. names end with N. Example, CH3Cl, chloromethane, C2H5Br, bromoethane. Alcohol, OH, names end with ol. CH3OH, methanol. C2H5OH, ethanol. Third, aldehyde, CHO, names end with R. HCHO, methanol. CH3CHO, ethanol. Carboxylic acid, COOH, names end with oic acid. Example, HCOOH, methanoic acid. CH3COOH, ethanoic acid. Fifth, ketone, C double bond O. CH3COCH3, propanone. CH3COC2H5, butanone. Homologous series. Homologous series is a group of carbon compounds having similar structures, similar chemical properties and whose successive members differ by CH2 groups. Example, alkanes, alkenes, alkynes, etc. Alkanes have general molecular formula CN H2N plus 2. Their names end with N and members are as follows: methane, ethane, propane, butane, and pentane. Alkenes. Alkenes have general formula CnH2n. Their names end with -ene. The members are as follows: ethene C2H4, propene C3H6, butene C4H8, pentene C5H10. Alkynes. Alkynes have general molecular formula CnH2n-2. Their names end with -ine and members are as follows: ethane C2H2, propyne C3H4, butane C4H6. Chemical properties of carbon compounds. Combustion. Carbon compounds burn in oxygen to form water, carbon dioxide, heat and light. Example, carbon plus oxygen molecules gives carbon dioxide plus heat and light. CH4, methane plus oxygen gives 2 moles of water plus carbon dioxide plus heat plus light. C2H5OH, ethanol plus 3 moles of oxygen gives 3 moles of water plus 2 moles of carbon dioxide, heat and light. Oxidation. Carbon compounds like alcohols are oxidized to carboxylic acids on heating with oxidizing agents like potassium permanganate, KMnO4, acidic potassium dichrome and K2Cr2O7. Examples, Alcohols are oxidized to carboxylic acid C2H5OH ethanol in presence of alkaline KMnO4 and acidic K2Cr2O7 and heat gives ethanoic acid CH3COOH. Addition reaction. Unsaturated hydrocarbon undergo addition reaction with hydrogen in presence of nickel or palladium as catalyst to form saturated hydrocarbons. Example, ethene undergo addition reaction with hydrogen to form ethane in presence of nickel or palladium as catalyst. The addition of hydrogen to unsaturated hydrocarbons to form saturated hydrocarbon is called hydrogenation. Hydrogenation is used to convert unsaturated oils and fats to saturated oils and fats. Substitution reaction. Saturated hydrocarbons undergo substitution reaction with halogens to form substitution products. Methane undergo substitution reaction with chlorine in presence of sunlight and form substitution products. CH4 plus Cl2 gives CH3Cl plus HCl. CH3Cl plus Cl2 gives CH2Cl2 plus HCl. CH2Cl2 plus Cl2 gives CHCl3 plus HCl and CHCl3 plus Cl2 gives CCl4 plus HCl. Some important carbon compounds. Ethanol C2H5OH ethyl alcohol. Properties. Ethanol is a colorless liquid with a pleasant smell and burning taste. It is soluble in water. Ethanol reacts with sodium to form sodium ethoxide and hydrogen. Ethanol reacts with hot concentrated H2SO4 to form ethene and water. Concentrated H2SO4 is a dehydrating agent and removes water from ethanol. Uses. Ethanol is used for making alcoholic drinks. It is used as a solvent. It is used for making medicines like tincture, iodine, cough syrups, tonics, etc. Ethanoic acid CH3COOH acetic acid. Ethanoic acid is a colorless liquid with pungent smell and short taste. It is soluble in water. A solution of 5% to 8% ethanoic acid in water is called vinegar. Esterification. Ethanoic acid reacts with ethanol to form ester, ethyl ethionate in presence of concentrated H2SO4. The reaction between carboxylic acid and alcohol in presence of acid to form an ester is called esterification. Saponification. When an ester reacts with sodium hydroxide solution, the sodium salt of carboxylic acid and parent alcohol are formed. This reaction is called saponification. Ethyl ethionate reacts with sodium hydroxide to form sodium acetate and ethanol. Ethanoic acid reacts with bases to form salt and water. Ethanoic acid reacts with carbonates and hydrogen carbonates to form salt and water and carbon dioxide. CH3COOH plus sodium carbonate Na2CO3 gives CH3COONA plus H2O plus CO2. CH3COOH plus NaHCO3 gives CH3COONA plus H2O plus CO2. Soaps and detergents. Soaps are long-chain sodium or potassium salts of carboxylic acids. Example, sodium stearate C17H35COONA. Structure of soap molecule. A soap molecule has two parts. A long hydrocarbon part which is hydrophobic, water repelling and soluble in oil and grease, and short ionic part which is hydrophilic, water attracting and insoluble in oil and grease. Cleansing action of soap. When soap is dissolved in water, it forms spherical structure called micelles. In each micelle, soap molecules are arranged radially and that Hydrocarbon part is towards the center and ionic part is arranged towards outside. The hydrocarbon part dissolves the dirt, oil, grease and forms an emulsion at center of the missiles which can be washed away by water. Detergents. Detergents are long-chain sodium salts of sulfonic acids. Soaps do not wash well with hard water because it forms insoluble precipitates of calcium and magnesium salts in hard water. Detergents wash well with hard water because it does not form insoluble precipitates of calcium and magnesium salts in hard water. Soaps. Soaps are sodium salts of fatty acids. Detergents. Detergents are sodium salts of sulfonic acids. Soaps cleans well in soft water but do not clean well in hard water. Detergents clean well with both hard and soft water. Soaps do not clean as well as detergents. Detergents cleans better than soaps. Soaps are biodegradable and do not cause pollution. Some detergents are non-biodegradable and cause pollution.